Hi guys, thank you for being here. And today we are talking about basics of Android application hacking, about unpacking, disassemblation, and some protection methods. But for beginning, I have two warnings for you. First one, this slide is really for newbies, so if you have already unpacked some APK, just pretend that you are interested in. Second one, it's please stay on the light side of force and be aware that reverse engineering can be illegal in some countries, in some cases. So let's begin. For today, we have two aims. One, strategic, make overview of unpacking, disassembling, and protection methods of Android applications. And second one, tactic. We will play this tiny Android application and remove from it conditional operator. We will perform if operator demolition. To achieve these goals, we will talk about reverse engineering methods. After this, how we build APK, what tools we can use for analysis. After this, the most interesting part, small demo, real live demo, so I hope that nothing goes wrong. And defense approaches at the end, how we can protect ourselves from bad guys or girls. So, reverse engineering, what is it? Reverse engineering, it's when we try to understand structure and reproduce behavior of something, but we don't have any information from creators of this something. But why someone might try to unpack your app at all? There are several reasons. First one, to repack your application. So this hacker will get your APK, unpack it, remove your advertisement, put his advertisements or her, and or in worst case, add some malware, pack this application again, and publish it into some Chinese app market. Another reason is to analyze algorithm and reuse this algorithm or re-implement this algorithm in another application. Or use your application is open documentation for your private API. And the last reason, to just steal resources, lovely pictures from your game, or a database from your dictionary application. So, there are two main methods of reverse engineering. First one, dynamic. It's when we start application and observe information exchange of it. We get logs from this application, we make memory and storage dumps, we look at network communication, but today we are not talking about dynamic, but about static way of reverse engineering, about disassembly and decompilation. Disassembly, it's when we try to get representation of executable binaries in form of assembly language, or in case of decompilation, in high-level language. In Android, it's Java or maybe Kotlin. Yeah. On our demo, we will unpack APK. But to understand how we can unpack something, we should understand how it was packed. So, everything begins with Java files that are written by you or generated by someone. For example, with AAPT tool, it generates our file. All of you know, I'm sure. So, Java decompiler converts all these Java classes into class files. But as you know, Android's not working with class files, but with DEX files. So DX tool converts class files into single DEX file. And in nearest future, this step will be replaced with Jack compiler, and from Java sources we will get DEX file. But anyway, after this, APK builder gets generated DEX file, resources, and SO files that are result of compilation of native part of your application, and pack them into APK. APK is very like jar archive. Actually, it's ordinal zip archive. So we can use any tools from Java SDK to process this APK file. For example, we can use jar signer to sign this APK. Why we should sign in couple moments. And last step, we align our APK because aligned application can be loaded into memory faster. In result, we have such package. This package contains resources, Android manifest, and string resources in binary form. Why in binary? Because of performance reasons also. And most interesting part for us, DEX file with executable binaries. Also, there is meta-inf directory with standard Java manifest and 2 files that are added with jar signer. But why at all we should sign our application? There are 2 reasons. First one is integrity. What does it mean? Integrity means that you must be sure that user on his device will install the very same application that you built, and no one adds any changes to this APK. The second reason, Android security system uses these signatures. For example, 2 applications that are signed with the same key can work in same process. So, jar signer adds these 2 files. Android RSA is a certificate that contains your public key and some information about you and your certification center. And Android SF. Android SF is a list of all members of our package and their hashes. Actually, only this file is really signed. But it's enough, because on your side you can calculate hash of any file and just check if it equal to hash from this file. Couple words about DEX and differences between Java bytecode or class files and DEX file. First big difference is that Java virtual machine is stack-based virtual machine, and DEX format is designed to work with register-based virtual machine. What does this mean? In stack-based virtual machine, before operation call, we put operands into some stack. And operation works with this stack. It pops operands from this stack and push result into it. In register-based VM, we put our operands into registers and pass identifiers of this register into operation. And operation passes result into third register. Why it's better for mobile devices? Because most of modern CPUs use register-based architecture. And if bytecode is already register-based, it's easier to convert it into real binaries. Virtual machine can be smaller and simpler, and it's important for mobile platform. Another big difference is that there are a lot of class files, single Java class, single class file, but only one DEX file. It's because all stuff in DEX file methods, classes, variables uses the same structures, same namespace, same virtual method table, and it makes DEX smaller. Also, one single file, big file, can be compressed more effectively than many small files. We are near our demo, but what tools we can use? First of all, we can use APK tool. APK tool is a set of different tools of assembler and disassembler, resources and manifest and packer, and you can perform next scenario. You can unpack some application, modify it, and pack it again. It's really powerful stuff. Next tool is DEX to jar. DEX to jar allows us convert DEX files back to jar file with class files. And class files can be decompiled with any Java decompiler, and there are a lot of Java decompilers. All these tools are open sourced and consequently free. Couple words about assembler for DEX format. It calls Smalley and backsmalley. Smalley and backsmalley stands for assembler and disassembler in Icelandic language. Why Icelandic? Because Dalvik is the name of fishing village in Iceland. And the syntax of Smalley is loosely based on Jasmine, and Jasmine is de facto standard assembly language for Java bytecode. And Smalley is very powerful. It supports full functionality of DEX format. And there is really simple example. Here you can see Java representation of methods that works with two integers, sums them, and returns integer. On this part, you can see smaller representation of it. As you can see, signature is very same in Java and Smalley. After this, we define how many local registers will be used as local variables in our method. After this, which parameters will be passed into this method? Some debugging information, in this case line number, and the most interesting line for us, main operation, add int, and return. So we are in one step from our demo, and this is our plan. We will get APK from a device or emulator and pack it with APK tool, make some modification, pack it again, sign, and install. So, demo time. For this demo, I prepared really simple application with single edit text, and if we enter some super duper secret password into it, it will show us some secret. But we don't know this password, so what we can do? We can assume that sources of this application contains some check, which some if that checks if entered password is equal to right password. So if we will remove this condition, any password will pass. First step is to get APK from our emulator. For this, we will use package manager that will list all packages on our device. And we know that application called, oh, maybe you can't see this, but it called crackme app. So we will grab all our packages with crackme. Here it is. Now we know where is this APK stored on device, and we can pull it. Unzip it. As you can remember, this is just a zip file. And this unzipped directory contains DEX file with DEX to jar tool, we convert our DEX file again to jar file with class files, and also unzip it. After this, we use APK tool to unpack our base APK and get Smiley codes. To view all these files, we will use Android Studio, because Android Studio is surprisingly powerful tool for reverse engineer. It contains built-in Java decompiler, Fernflower, maybe the most powerful Java decompiler at the time. Also, it can show you structure of APK. Some magic. Yeah. Structure of APK and resources and manifest and human readable form. So presentation mode will help us. Oops. So here we have unpacked jar. So there are 3 packages. 2 of them are well known, support library and butter knife. Third one is custom one. It's interesting. So it's really small. We can see that here it is, main activity. And now we use Fernflower to decompile them. Main activity is very tiny. It contains some secrets, but it's not our main goal. Our main goal, so there is some edit text with text changed listener, and on text change we perform this check. So we should remove this if. Let's copy name of this method, and now we try to find it in our Smiley code. Oh, what a surprise! There are 2 main activities. But it's because our text watcher is anonymous class, so it compiled into separate Smiley. I think here it is. We are looking for this method. Some uninteresting stuff. On text changed. Thank you. Appreciate. Header. Not interesting. Oh, constant with our password. And if operator. Yeah, equals method call and some if operator. I think we should comment it. So now we are ready. And one cool thing in Android Studio, you can open APK class, and it will show you structure of DEX file, Android manifest in human readable form, any images. So it's really powerful tool. But now we commented our if operator, and we are ready to pack our application with APK tool again. So now app directory will be packed into cracked APK. And after this, we will need to sign this APK with jar signer. To make this, I will use debug key store, because if you have installed Android SDK, you definitely have debug key store. And you will be able to debug this cracked application. It's cool. So yeah, now we have cracked APK, and we should remove our old application because it's signed with different key, and install new one. And let's check. Oh, so important moment. Ooh. Here it is. We made this. But as you can see, it was easy. So what we can do to make this harder? Some errors with real application, yeah? Maybe it will be definitely not so easy. But there are two main approaches for Android application protection. First one is obfuscators. It's when we transform our code and make it less readable. We rename methods, rename classes, add some junk code, and packers. Packers is when we encode our binaries and make static analysis impossible. Both of these approaches use security through obscurity principle. And this principle doesn't really make impossible unpacking of your application. It's just make reverse engineering process slower. But anyway, it's only option. So obfuscator. In contrast to x86 binaries world, Java binaries contains all strings in human readable form, and it makes life of hacker really easy. So obfuscator can rename all these classes and methods, and it's what ProGuard does. And I'm sure all of you uses ProGuard. Also, it can encode names with some strange codes, shrink unused resources, or instead of this, add some junk code. But it will take some time of reverse engineer to understand that this code does nothing and make code less readable. Obfuscation can be applied on two stages, on class files and on DEX files. ProGuard works with class files. It's because ProGuard was created in 8 years before Android, and no one known about Android in this time. And actually, it's why ProGuard can be used with any Java project, not only with Android. This is example of code shrinking and renaming. On left side, this is that application from demo in unpacked form. On the right side, obfuscator renamed everything, make names smaller and less readable. So it's win-win combination because it makes DEX file smaller, and now you can't. It's weird structure, maybe a little bit weirder than on the left side. Another approach is string encryption. As you remember from our demo, it was really easy to see password in our code. So we should do something with this. For example, we can store our secret code or key, API key, any string in encrypted form. And we use for this some really basic encryption. In this case, I used XOR to restore string form of this password. I iterate through this array and perform XORing again. And now we have original form of this password. In smaller form, on left side before encryption, this is encrypted one. So it's definitely less readable. Of course, if you know about this approach, you will be able to get initial form of password, but at least it will take some time. And string encryption plays really well with reflection. For example, 10 minutes? Oh, okay, thank you. For example, you try to call system exit method, and you can do this with reflection, with class for name, string representation of class, not representation, but name, string name of methods, and string form of argument. And now all these strings can be encoded. In this case, I use just base 64 form, but at least it's not so obvious what's going on here. Again, everyone can reverse it, but it takes some time. And if you try to not to give your algorithms away, you can hide algorithm in native part of your code. It's way more difficult to decompile native binaries than DEX files. But remember that this is still possible. There is such tool as IDA Pro, so everything possible. And someone can reuse your sources even without decompilation. Sorry, not sources, but binaries. Another approach, packers. Packers, it's when some program gets your APK, extract your DEX file, and mangle or encode it. And after this, it made wrapper around this encoded DEX. And now, if you will use your APK tool and DEX to jar, you will not be able to decode this DEX and get some readable sources. After this, user, this smiley guy, starts application. This application loads native library from wrapper. Native library performs some anti-emulator and anti-debugging tool. It can check some environment variables and say, okay, it looks like we are running on rooted device or on emulator. So let's go to infinite loop. Or just crash ourselves. Yay! But if everything is okay, this native lib loads encoded DEX and decode it. After this, it uses DEX class loader to start your application. Of course, attacker is able to make memory dump of your application and get encoded DEX file from your memory. And from this encoded form, he will get smaller representation. But it's more complex way. Of course, you can implement all discussed tricks by yourself. But there are some already created tools. ProGuard. I don't know any person who doesn't use ProGuard, but ProGuard doesn't really give any protection. It minifies your code, but it's not about protection. There is a proprietary version of ProGuard called DexGuard. It performs all tricks that we are discussed, except packing, but it's not really cheap. It costs $500 per one license. Also, there is smaller brother of it, Aleatory. It's slightly less complicated and slightly less pricey. It costs only $300 per one license. Also, there are a lot of Chinese packers. I don't know why, but Chinese people really love packers. And all of them works in next way. You upload your APK into cloud, they encrypt it and gives you back encrypted file. No, it works, but all sites in Chinese, so I even don't know how much does it cost. And interesting fact that creators of malware widely use packers because they have this virus, they encode them, and antivirus scanner can't understand that this is actually malware. Oh, okay. Yeah, summary. I think 5 minutes will be enough. Don't store secrets in your code, please, because as you can see from demo, it's really easy to unpack your application and get any strings from it. So from unpacking point of view, Android sources is something like JavaScript code, and no one, at least I hope, stores secret in client-side JavaScript. Also remember that smartphone is not a trusted environment. Hacker will be able to get from device anything and modify any modules on this device. And all approaches that we discussed use security through obscurity principle. As I already said, this principle doesn't stop but slows down reverse engineering process. And everything can be hacked. It's just a question of resources and time. And all these approaches that were discussed are good, maybe good protection from script kiddies, but not from real security professionals. So if someone really wants to steal your APK, it will be able to do this. Remember about this, and if you have any real secrets, store them on server side and make server really protected. This is the last slide. This is just sources that I used to prepare this presentation. If you want to go deeper, please read them. Really interesting stuff. Especially first one, it's guys from DEF CON. They talk interesting thing. So thank you for your attention. If you have any questions, you are welcome.
Hey, thanks for your presentation. I'm wondering how to use some kind of crash reporting tools with all this encryption stuff.
Oh, sorry, I just don't hear.
How to use crash reporting tools with all this encryption stuff.
Crash reporting tools?
Because you get messy code after encryption, right?
After obfuscation, you mean? ProGuard produces map files, and I think it's only way to restore the original stack trace.
If you use approach which makes your DEX file messy.
Encrypted?
Yep.
Finally, this encrypted DEX file will be in unencrypted form in your memory. So in result, it's no differences between ordinary app. Oh.
Any more questions?
Do you like security preference or something like this? Because a lot of people save that, for example, token application, they saved in preferences, and a lot of guys say that it's not true way, it's don't safety way, and they much prefer this security preference.
Okay. I think this is a question not about decompilation, but runtime storing. I think if you are okay that phone can be rooted, and so it's okay to use security preferences. But if it's some real secret, some banking information, maybe it's bad idea.
Okay, I have a question. Is there any possibility to make a memory dump to get that encoded DEX file on the device? Like, not to connect in ADB service and all the stuff, but just with your program code on the device side.
Decrypt your program?
No, to make memory dump to get access to all the encrypted DEX code.
As I know, people use ptrace to make memory dump, so they just found a Unix process on device and connects to them with ptrace. And
But you need root access, yes?
maybe, don't sure.